Hello students, I have learned the basic principles, hardware facilities, technology and applications of ultrasonic testing. In the specific implementation of ultrasonic testing, we must also be familiar with the relevant technical requirements of ultrasonic testing object. The implementation and acceptance criteria of ultrasonic testing, and there are rules to follow to achieve ultrasonic testing behavior. Just as in life, all our words and deeds must abide by the law, otherwise there will be chaos. Let's learn the standard NBT47013-2015, which is currently widely used. NBT47013-2015 is the standard recommended by the National Energy Administration. The evolution of the standard has roughly gone through 3 stages. 1. JB/T470-1994. 2. JB/T470-2005. 3. NBT47013-2015. In 2018, another revision was issued for the standard, and some of the contents were reversed. The scope of the target ranged from pressure vessels to special equipment to pressure equipment, and the scope of the standard was gradually expanded. It can be seen that the market application scope of this standard is very broad. This is one of the reasons why we choose this standard to introduce. Content of the standard. A total of 13 parts are included. The first part is general requirements, and the following contents correspond to 12 non-destructive testing methods such as radiographic testing, ultrasonic testing, magnetic particle testing, penetrant testing, and eddy current testing. The provisions of the general requirements apply to the following 12 non-destructive testing methods. They are all suitable for non-destructive testing of products in production and in service. The following is a brief explanation of some of the key contents directly related to ultrasonic testing, mainly related to or affecting the detection sensitivity and the quality classification of the detection object. In the ultrasonic testing part, according to the different testing objects, the standard stipulates the ultrasonic testing content of raw materials and their parts. We select the ultrasonic testing of plates, ultrasonic testing of forgings, and ultrasonic testing of welded joints to introduce them one by one. First, let's look at the ultrasonic inspection of the plate. 1. Scanning method. There are 4 regulations in total. 1. Perform 100% scanning on the edge of the sheet or on both sides of the predetermined line of the cut. The scanning area is shown in Table 5. When the plate thickness is less than 60 mm, the corresponding detection area width is 50 mm. When the plate thickness is between 6 mm and 100 mm, the corresponding detection area width is 75 mm. And when the plate thickness is greater than 100 mm, the corresponding detection area width is 100 mm. 2. In the middle area of the plate, the probe is scanned along the parallel line perpendicular to the rolling direction of the plate with a spacing of no more than 50 mm. Or the probe scans along the grid lines perpendicular and parallel to the rolling direction of the sheet, and the spacing is not greater than 100 mm. 3. According to the requirements of the contract, technical agreement or drawings, other methods of scanning can also be used. 4. When the dual element probe is scanned, the moving direction of the probe should be perpendicular to the sound insulation layer of the probe. 2. Sensitivity. When the thickness of the plate is less than or equal to 20 mm, use the test block with the step flat bottom hole shown in Figure 1 to adjust, or it can be adjusted with the intact part of the inspected plate without defects. The primary bottom wave is adjusted to 50% of the full scale and then increased by 10 dB as the reference sensitivity. When the plate thickness is greater than 20 mm, draw the distant amplitude curve on a 5 mm flat bottom hole test block according to the probe and instrument used, and use this curve as a benchmark sensitivity. If the relationship between the echo from the bottom of the plate and the amplitude of the reflected wave from the flat bottom holes with different depths of 5 mm can be determined, the first bottom wave of the intact part of the plate without defects can be used to adjust the reference sensitivity. The scanning sensitivity should generally be 6 dB higher than the reference sensitivity. 3. Plate quality classification. Please look at the new Table 6. These two tables are contents of additions and changes, which will be implemented from July the 1st, 2018. The new table adds an extra level. It can be seen from the table that the quality classification of the middle of the plate is based on the size of the single defect. When the thickness of the plate is less than or equal to 20 mm, the area of a single defect is used to indicate the area. The indicated area here refers to the defect area measured according to the detection method specified in the standard. When the plate thickness is greater than 20 mm, it is recorded as 5 plus the corresponding decibel value. Another classification is based on the size and the number of defects within a square meter area. See new Table 7 for the grading of the edge and the sheet of both sides of the pre-cut line. It can be seen from the table that the quality classification is based on the maximum allowance signal defect length, the maximum allowance signal defect indication area or its equivalent size, and the number of defects within the specified defect length range or size within any 1 - meter length. Let's look at the relevant requirements for ultrasonic testing of fortune. 1. Determine the sensitivity. Use CS-2 or CS-4 test block for reference sensitivity of single crystal straight probe. Test a group of 5 2 mm flat-bottomed hole, at least 3, with different distances in turn. Makes the distance amplitude curve of single crystal straight probe, and use this serves as the reference sensitivity. When the thickness of the inspected part is greater than or equal to 3 times the length of the near field area of the probe, and the inspection surface is parallel to the bottom surface, the base wave calculation method can also be used to determine the reference sensitivity. The reference sensitivity of the dual crystal straight probe is CS-3, and a group of the 5 2 mm flat-bottomed holes, at least 3, with different distances are tested in turn to make the distance wave amplitude curve of the dual crystal straight probe, and use this as the reference sensitivity. 2. Quality classification. The quality classification of a single defect is directly based on its equivalent size, as shown in Table 13. The amount of bottom wave reduction caused by defects according to Table 14. The amount of bottom wave deduction here refers to the decibel difference between the height of the bottom wave when there is the defect and the height of the bottom wave in the intact area near the defect. 3. Ultrasonic testing of welded joints. 1. Detection area. The detection area refers to the area where the detection object should be detected. For welded joints, it is characterized by the detection zone, width, and thickness, including the weld and its heat-affected zone. Since the width of the heat-affected zone is different for different welding methods, the exact width of the heat-affected zone should be determined by hardness measurement or observation of a metallography structure. For the sake of uniformity here, the standard stipulates that the width of the detection area should be the weld itself plus 10 mm on both sides of the weld fusion line. Take the V-shaped groove as an example, as shown in the figure. 2. The width of the probe moving area. The width of the moving area of the probe is to ensure that the ultrasonic beam can scan all the defects in the inspection area. Its width requirements are shown in the figure. The width of the moving area of the probe should not be less than 1.25 times the spacing during the detection by the single reflection method. It should not be less than 0.75 times the spacing when detected by the direct method, where P is the span. 3. Scanning method. The scanning methods of the welded joints include zigzag scanning and 4-bay scanning methods. The zigzag scanning method is shown in the figure. Its purpose is to find defects. The other 4 basic scanning methods include front and rear, corner, surround, and left and right scanning as shown in the figure. The purpose of front and rear, Corner and surrounding scanning is to find the highest echo of the defect. The purpose of the left and right scanning is to measure the longitudinal length of the defect. 4. Detection sensitivity. The ultrasonic testing sensitivity of welded joints shall not be lower than the evaluation line of the distance amplitude curve. The distance amplitude curves were drawn using CSK-IIA and CSK-IIA transverse through hole test blocks. The specific requirements of sensitivity shall be implemented according to Table 27 and 28. 5. Quality classification. The 47013 standard specifies 3 types of welded joints, that is, boiler and pressure vessel tube circumferential and longitudinal welded joints. Pressure pipeline circumferential and longitudinal welded joints and their quality levels are divided into 3 levels. The qualities classification of the welded joints of boiler and pressure level body is carried out according to Table 33 respectively. It can be seen from the table that the basis for evaluating the quality level is the highest amplitude of the defect echo, the indicated length of a single defect, and the cumulative length of multiple defects within a certain range. The quality grading of circumferential and longitudinal welded joints of boiler and pressure vessel pipes is carried out according to Table 34 respectively. It can be seen from the table that the basis for evaluating the quality level is the highest amplitude of the defect echo and the indicated length of a single defect. The quality classification of circumferential and longitudinal welded joints and pressure pipelines shall be carried out according to Table 35 respectively. It can be seen from the table that the evaluation of the quality level is based on the highest amplitude of defect echo, the indicated length of a single defect, and the indicated length of the incomplete penetration of the root of one-sided welding of the circumferential welded joint and its accumulated length. The most commonly used content in the NBT47013 standard is introduced here. The measurement of the attenuation coefficient and the scanning coverage rate, etc., which still need everyone to read and understand carefully. Thank you all for watching.